This is assignment 2 of CSC480, game of dots and boxes with alpha and beta pruning algorithm. Here you can play 2 by 2, size and ply, and start the game. You play, AI plays, score, size, ply, then you can just simply this thing, and same goes with 3 by 3, even if we go this way. So AI thinks and puts some steps in. Same as with 4 by 4, we do this way, things and sets up this. Same goes with 5 by 5. By 5 it takes around 10 seconds to make a move, and it makes in a pattern. So let's dig into the code. In this code, it's a Flask application with Python. There's a normal get node for index HTML, then inputs to take size and ply, and then inputs to take line click, which is basically the coordinates of the line, and return back new state to render the HTML. First, going through the node. So there are 3 types of nodes in this game: horizontal line, vertical line, and boxes. So this is class node, where who is it owned by, what is the value, what is the coordinate, and what is the type. State is another important piece, where it defines the state of the matrix or the game any given point of time. It takes the size, ply, scores, line dictionary, and box dictionary. So it also exposes a function called check score, where it calculates, going through all the box dictionary items of box dictionary, calculates the score, and also determine if the game is still running or it's over based on number of box completely filled. Checkboxes: anytime a horizontal line is clicked, we check the top and the bottom. Anytime vertical line is clicked, we check the left and the right to verify if the box is completed or not. There's a successor function which gives the child states from a particular node, and depending on who it makes that state of the one line or one by human or this, and hits a list and sends it back. And then terminal state is used in algorithm to see if is there still any boxes available, or is it a terminal available kind of a thing. Going to the min max. So we initialize size and ply, we initialize 2 by 2 matrix. Horizontal row will have 0 dot followed by horizontal line. Vertical line will have odd lines will have vertical line followed by a box. So that's basically the initialization piece. Then whenever a human makes a move, we take the coordinate, we assign the owner to human, and then check the box. If box is completed, then allow AI to move, calculate the score, and send back the state to the UI. Now AI move basically is it goes through, copies the state, and calls the algorithm function, and copies the new state and send it to overwrite the state. Now copy is just to make sure no references is left. In this one, algorithm min-max is done by going through the child. If the value of the child is greater, there's a new max. But for alpha beta pruning, what we do is check with the beta in case of max, and break if it is greater, then alpha is set. Same is case of min function, where value is less than we initialize it with max, and then if it is less, it goes to the new value as assigned to the value, and if it is less than alpha, then we break it so that the tree is not traversed. We set the beta. I'm using a tuple to return back because we need a state which we can send to the UI. So value is used in the algorithm to make the algorithm work based on the value. So you see 0 here, and state is used in the return function, where you get the new state and make a copy of it and override the current state. So that's pretty much on this. Yes, thank you.